Good evening. Thank you so much for being here this evening. It's delightful having you take your time and being here to hear about our Math and Focus program. I want to thank Mr. David Lieberman. He's hosting the workshop in his school, and he's now doing the videotaping. Didn't plan on that, but he is. And our presenters are our group teachers, unlike last year. We have Justin Kerr, who teaches first grade here at Ross Elementary. He's also the elementary math curriculum leader. And we have Cody Russell. He is the librarian here at Ross, and he is the elementary librarian, elementary K through 12 curriculum leader. It's social studies. Okay, social studies curriculum leader. And Carol Nelson teaches first grade at McIntyre Elementary. This is her third year in the program. She participated in the pilot year, as did Justin 3 years ago. And she's here to talk K through 2 program, which she knows very, very well. If parents have a question about that, or even the progression of skills. So I want to turn the program over to them, and then we'll have a question and answer session afterwards. Thank you.
Good evening, everyone. Again, thank you for spending some time with us this evening. Our plan tonight is to give you an overview of the Math and Focus program and talk a little bit about the philosophy of the program and show you a little bit about what it's going to look like for your students, for our students, and what it's going to look like for you at home, and just give you a little bit of background, and then we'll answer any questions that we have. So we want to start out with just some background information for you about Singapore and how this program came to be. So over 20 years ago, Singapore it's a small island country of about 4 million people, and they realized that, being a small island country, they did not have a lot of resources that were going to continue to support the growth and development of their country. So they made the decision that the best course of action for them was to invest in their people. So they invest heavily, and they made the decision to invest a large portion of their federal government spending in education. And so they took this TIMSS assessment about over 20 years ago, which is a international math and science assessment that's given about every 4 years to nations all around the world. And when this assessment was first given in Singapore didn't score very well. They were down about halfway down the list. So what they looked at was, well, how can we improve? What can we change about our mathematics instruction? So their Ministry of Education decided that they were going to kind of take a road trip around the globe and look at best practices in mathematics instruction all across the globe. So they traveled to Korea and Japan and Finland, and they came to the United States. And we're really working to identify what has worked in mathematics instruction all around the world. And that's how this program became developed. And so once this curriculum was developed and approved by the Ministry of Education in Singapore, the results immediately shot to the top. And over the past 20 years, Singapore has scored either first or second on the TIMSS every time the assessment has been given. Many of you have heard a lot about the change that's going on in our own country, about adapting to and moving from state academic content standards to moving to Common Core state standards, which have more of a national focus. 45 states have adopted the Common Core standards, and then each state is kind of tweaking it a little bit and making it their own. And really what Common Core has identified is that when they looked at mathematics instruction in the United States, they found that textbooks are often very weak, and the presentation is focused more on the mechanical procedure rather than developing a concept in great detail. So, and that's been the case when they looked at both traditional and non-traditional textbooks. They found this conceptual weakness in the majority of these programs. So we know that from looking at research that mathematics education in high-performing countries like Singapore have pointed to the conclusion that mathematics curriculum in the United States has to be more focused and coherent. So it's kind of this idea of moving from a mile wide to an inch deep to a mile deep and an inch wide. So kind of a change in a thought process here about how we teach math. Okay? So there's some overarching ideas in the Common Core state standards, and these are the same overarching ideas that Pennsylvania has identified for our Common Core math standards. And they're referred to as standards for mathematical practice. So these are 8 key ideas that we want students to be able to do given any question, any concept. Okay? So, and these are things that aren't necessarily been valued in a traditional procedural approach to mathematics. Okay? For example, make sense of problems and persevere in solving them. We want to build up their stamina when it comes to engaging in problem solving. Okay? Many students, when they're faced with an opportunity to engage in a problem that's difficult, become frustrated. But we all face challenges like that on a daily basis. So how do you deal with that? How can you identify an entry point into a problem? Because every student, every person has a different background knowledge that will give them an entry point into solving a problem. Being able to reason abstractly and quantitatively. Being able to construct their arguments and critique the reasoning of others. So there's a strong focus on developing that math talk, being able to think about what you're doing in math, metacognition piece of things. You'll see here in a little bit, the modeling of mathematics is a huge part of it, using manipulatives and using concrete objects. And that goes hand in hand with using appropriate skills, using appropriate tools strategically. And of course, there's always an element in mathematics of precision. Making sure that we get that correct answer, and then looking for things such as structure and regularity that help us explain why things happen the way they do in mathematics. So this is the mathematics framework that this Department of the Ministry of Education in Singapore developed. So at the core, what they've established is at the core of all mathematics teaching and learning, for that matter, is based on the idea of mathematical problem solving. That's what we want our students to be able to do. We want them to be problem solvers. So they developed this pentagon that said each one of these sides is equally important, and we have to work as teachers to develop each side of the pentagon equally. And when we are able to do that, and students are able to develop their skills and have a strong, deep understanding of the concepts, recognize the processes that take place in mathematics, and have a discussion about their thinking in mathematics. Metacognition is thinking about their thinking, as well as having a positive outlook and attitude about mathematics as well. That's a huge part of it. That those 5 things together, when developed strongly, equally, will provide a student with a strong basis to be mathematical problem solvers and to be proficient mathematicians in school and in the real world in the future.
So within our program, we have 3 main components that we try to draw. The first, whenever a lesson begins, we draw on solid prior knowledge. Anytime we're beginning a lesson or a new concept, we make sure that we are assessing and drawing all the prior knowledge students bring within a lesson. Now, the major difference we have is that we focus on the why and the how, which we call our interlocking concepts and skills, kind of together. So typically in the past, when students would work through an algorithm, that's something that is procedural, where they know to carry a number or to go through the problem, typically like they were taught. We're focusing now a little bit differently, where instead of just knowing how to follow a procedure, we focus instead on why does an algorithm work. So if we're taking, let's say, 6 times 3 is 18, before we were told to put down the 8 and carry the 1. Instead now we're talking, why are we doing that? Because we're regrouping. And we're taking our 10 ones and regrouping them as a 10. So it's a different approach we take now, where we're kind of combining the 2 together to really give us that how and that why. And it foreshadows future concepts as well, because as we continue working, everything we're doing builds. If you take something like division, where we start already in first grade with the idea of equal groups. And then in second grade, it would move on to continue with the division symbol being introduced. And I have a slide a little later to show you a little more detail of that. But it's a progression that we're really focusing on. So we're really building background knowledge for the students and helping to progress their skills. Each one of our lessons follows what we call the CPA cycle. CPA stands for concrete, pictorial, and abstract. Each lesson begins at the concrete phase. This is where the students and the teacher both are using the manipulatives. They're introduced through the manipulatives. Students are working with them. Teachers are actively working with them as well as they're instructing. As we move beyond the concrete level, we then move to our pictorial level. This is when the students are starting to move out of the concrete stage and more to a pictorial representation. In the pictorial representation, there are many pictures and graphs to help the students to effectively understand the concept that they're being taught. And we eventually move to the abstract level at the end, which is where we have completely moved from the concrete and pictorial stages. And at the abstract level, we're using numbers and symbols instead. So we've transferred through our 3 stages of a lesson. Something that we focus on in this program also is that we go very in-depth within a specific chapter, within a specific lesson, and we teach to mastery, which is a little bit different than before. We actually have fewer topics within a chapter that we'll be teaching, and it allows us to spend more time to teach to mastery within an individual lesson. And the example you have here, this is our chapter overview, and within the chapter overview, we have the first 2 lessons, as you can see, are 2 lessons on place value. Place value is very, very important and integral to our program that students understand place value. And we spend 2 days on our first lesson on counting, and we spend 2 days on our second lesson on place value. So this gives us a little more flexibility to go a little bit deeper into the topics. Not having as many chapters or as many topics to teach, we can spend more time and really teach those topics that we do have in depth more. So the question is, how will it look different? It will look different 2 ways. It will look different in school for students, and it will also look different at home for parents. In terms of in school, we have this idea of teaching less and learning more. And this is what I was mentioning earlier about being able to teach in depth, where we start with a concept early on and we continue to develop that concept as the students progress through the grade levels. With the idea of division, which I mentioned earlier also, we have in first grade, we're already starting with the idea of creating equal groups. So the students work with the idea of what does an equal group look like, how do I create an equal group. In second grade, they're introduced to our division symbol. So they're taking those groups and now seeing how we can divide into equal groups. In third grade, we start dividing with remainders. In fourth grade, we continue building and have multi-digit by single-digit division problems. And then finally, in fifth grade, we start dividing with fraction notations. So it's a consistent process that we use when we're really trying to build each year and develop this mastery by introducing concepts early and continuing to build each year on them. So a typical lesson structure, there's 4 main parts of the lesson that we go through. And this is where it will be a little bit different in the classroom as well. And it always starts with what we call the teach and learn section. This is the section of the lesson where we're in the concrete phase, where the teachers have the manipulatives, the students have the manipulatives in their hands. And we're working at the same time as we're manipulating and getting that concrete understanding of the topic that we're working on. Which then leads into our guided practice section. This is where we move to more of a pictorial representation of our lesson. Within this part, we might be doing games in the classroom, hands-on activities. Let's explore, which allows the students to explore a little more of the topics that they're learning, and practice problems that are embedded within the lesson. So in going through those steps, you'll notice there's arrows both ways, because if we are introducing more than one skill or concept at a time, we kind of repeat back into the teach-learn section again with the manipulatives and the guided practice. As we master each individual topic that we're going through in each lesson, we move to the let's practice section. This is the student's first chance to show what they know. Within a lesson, we have the let's practice, which are the problems that move to more of the abstract level with our numbers and symbols. There is no manipulative use at this time, and we really move towards those students being able to demonstrate either with pictorial representations or just by looking at the numbers and symbols, their progression of learning. And then finally, we have our last piece, which is the workbook. The workbook for us is the proof, not the practice. We are looking at that point for the students to be able to prove to us that they really understand and have mastered the topic that we're working with. It says in-class/homework. You might see some homework pages that come home in the workbook, but typically that's our proof more than anything else that the students understood and mastered the concept that we kind of look for in the classroom.
Looking a little bit more at what you can expect to see to come home, as Mr. Kerr talked about, that workbook is meant to be a master's tool. So that's where we want our students to be showing that they understand, which is a pretty major change from what homework has typically been in math, where it's just a practice tool. So in terms of what it's going to look like when it comes home is there's usually going to be a lot of examples on there so you can see as well of exactly the methodology that's being used and see that process of moving through concrete, pictorial, abstract as well within the homework. There's still, the obvious goal here is that we're still moving students to use those standard algorithms. That's the abstract piece. We're just starting with concrete and pictorial to build that conceptual understanding of what truly division is or what truly multiplication is. Okay? Typically fewer problems, but the questions are usually at a higher level. So rather than just recalling how we multiply, we want students to be able to apply their knowledge and synthesize and evaluate a given question and decide what the best course of action is to get to an answer. Okay. So we wanted to show you a little bit of how the pages progress. So these pages will all be from the same lesson. So this is a sample lesson on comparing and ordering numbers, and this is what a workbook page would typically look like compared to a reteaching tool, which you may see as well. So a reteaching, you may see that if a lesson is more than one day, this is a tool that a teacher may use to support your students in reviewing a skill as we continue to build that mastery knowledge. So again, we've got some scaffolding in here that's showing you and the students exactly how that skill was taught and enrolled in instruction. And extra practice is another option that you may see. Again, it's going to offer additional practice for a student. And then there's also an enrichment component, which again is what we're driving to with all students, is that higher level of thinking and being able to problem solve.
And if you noticed also as we were going through those slides, as we moved to the extra practice, it was completely abstract, where we lost all of our pictorial representations and we have just our numbers and symbols. That's the point we'd like to have the students at, where they understand and they're able to show us their knowledge without having to use the pictorial representations through the workbook pages. We're going to move next to a sample example for you of modeling division with regrouping. This is actually taken from 4th grade, and it is an example of modeling division with regrouping, where we have a 3-digit number being divided into 3 equal groups. So I'm going to walk you through kind of how we would use our manipulatives in class and what that would look like as we model our algorithm. Because again, we talked about this interlocking skills and concepts, where we really want to make sure as we're teaching our lessons that not only are we focusing on how does an algorithm work and how we would work through an algorithm, but why it works as well. So we're really trying to develop a dual knowledge there. So the example we have, of course, our objective is to model regrouping and division and to draw a 3-digit number by a 1-digit number with regrouping. Sorry to divide. So modeling division with regrouping in hundreds, tens, and ones. The example we have is that a farmer sells his crops to 3 restaurants. He divides 525 heads of lettuce equally among the 3 restaurants. How many heads of lettuce does each restaurant receive? So in a problem like this, we have a real-world connection where the students can see how this might be something that's applicable to our real-world lives, especially if you're a farmer and you would be dividing heads of lettuce. So to start a lesson off, as I mentioned, we start in that concrete phase, which would be using our manipulatives, which looks like this. And the way our manipulatives are set up, we have a place value chart at the bottom that breaks up our ones, our tens, our hundreds, also goes to thousands and 10,000s. And each chip is color-coded with a number on top of them. So at the beginning of a lesson, we would discuss how and where we would start our division process to go through a typical division algorithm. And of course, we would start and talk about how we always start dividing in the highest place value, which is our hundreds. And at looking at our chart, something else knowing that we have 3 groups, we also try to get the students in the habit of creating and showing what those 3 groups would look like. So just taking a dotted line across sometimes is a nice visual for them to see that we're creating 3 equal groups. And of course that number would change if we weren't dividing by 3. So starting in the hundreds, we have 500s. We would start discussion with the fact that we cannot have 500s placed into 3 equal groups. But we can place 100 in each of my groups with 200s that obviously would not equally fit into my hundreds. So we would then move into the discussion of what do we do with those 200s? And discussion would lead to the idea of regrouping, because we have 200s right now that we have to trade in and regroup. We're really focusing on the idea we're not borrowing anymore, we're regrouping. So we're taking our 200s and we're regrouping those, and instead we would trade in for a total of 20 tens ships. And I would show that I'm adding now 20 tens into my tens place value column. While this is going on, we can show in our algorithm, which is a little bit different now, because typically we've always talked about how 500s is being divided into 3 groups with 100 in each group. And we would typically write the 3 and then subtract to get the 2. But we're presenting it a little differently because we're trying to look at this as breaking up our 525 into equal pieces. Because I really did not just use 3, I used 300. And we can see that when we look at our chart, we have our 300s that have been equally divided. So instead, I have 225 left. What does that represent? That represents our 200s, our 2 10s, and our 5 1s. However, our 200s are now 22 10s. And we would point out and show them that we actually have 22 10s now that we're working with because of our regrouping. This is all part of the understanding how an algorithm works. We know how to work through and solve one, but we're really looking at what's actually happening. So we have 22 10s and 5 1s, which we can see on our chart. We then discussed if we could put 22 10s into equal groups. After discussion, we would see that we could put 7 10s into each group, and I'll divide that out. And we can put 7 10s into each group equally with 1 10 left over. So again, we discussed we have 1 10 left over when we do our division. What would we do with that last 10? And we discussed the idea of regrouping again. The students, at this point, we've spent many lessons on place value, and they understand that we can't have more than 9 within an individual place value. So we would take our 10 and we would trade it in for 10 1s as we continue dividing down. Going back to our algorithm, we can show that now we're in the tens place. We had to divide our 22 tens into 3 equal groups. We have 7 into each group. But typically, again, we would write 21, but now we're talking about how much we're actually working with. We have 21 tens, which is actually 210, to show that we have 15 left over. The 1 10 would be the 10 that we were regrouping into ones, and then we have our 5 1s originally to give us 15 1s left over. Once we get to that point, we're ready to finish off our problem. We look and see that we had 5 1s, we regrouped, we traded in for 10 more 1s. So if I add 3 more to each group, I end up with 5 1s in each of my groups. So the students right now have a visual representation of how we took 525 and equally distributed it into 3 equal groups. The last part of my division process, obviously, I had my 3 groups. I had my 15 1s, which was technically 1, 10, and 5 1s, but I did regrouping. So I had my 15 1s into 3 equal groups, gives us 5 1s in each group with no remainders, so we can find out that we have 175 heads of lettuce divided among each restaurant. Now again, the point is not so much to emphasize the differences we're doing in our algorithm, but to understand why. And before, we really didn't have that part, that why question answered, without the manipulatives and seeing the regrouping actually happening. So it allows the students to really see why we're dividing the way we are with being able to see that visual representation of regrouping. So we mentioned about the concrete, pictorial, abstract cycle that we tend to go through. Our concrete materials and our pictorial representation this time was in the use of our manipulatives. And the abstract level became moving and understanding the algorithm. This is, again, something that we're still using our algorithms, but we want them to understand what's actually happening in our algorithm. So they can show that deeper conceptual knowledge than not so much that I can just follow an algorithm, but I understand what's happening in that algorithm. And using the manipulatives gives us the ability to do this. Our second pictorial representation, this is from a student textbook taken in that 4th grade lesson as well. We would walk them through the process, and within each picture it shows them exactly where the regrouping is happening by circling the chips that would be moving to the next place value down, to a lower place value. And we would walk them through the idea of what we just did with our manipulatives, what we showed in our abstract example is all illustrated in the textbook as well.
Another key component of math and focus is this idea of bar models or model drawing. And really, the idea here is that it fits into the concrete pictorial abstract pedagogy that Justin spent a little bit of time earlier talking about, in that we can create a visualization of what a work problem is asking us. Research has shown that students are about 75 to 80% more likely to be able to solve the problem. Even if they may not know exactly how to go about it, once they are able to create a visual of it, they start being able to identify entry points into the problem. So bar models are nice because beginning in really 2nd grade, students are asked to move from that concrete stage into the pictorial stage where they can create a representation of what they're being asked in a word problem. So, as the first bullet says, parts and wholes. So, in a given addition or subtraction problem, word problem, when they're given 2 parts and we're looking for a total, or given a total and a part. We can also illustrate when we know certain givens and when we don't know, what we're looking for. And it helps students build that relationship, like I talked about a little bit earlier, between what they know, what they're given in a math problem. So it helps them visualize the relationship between, what they're being asked in the problem, whether it be, the number of beads 2 people have, or the number of baseball cards that are being shared, or the weight of a basket of apples, something like that. So.
And if I could just add quickly, something that we also do, we talked about the idea of building. And this is something where bar modeling is introduced in 2nd grade, but we build on that idea in kindergarten and 1st grade. In kindergarten, we start with the 10 frames, filling a frame of 10, which moves in 1st grade to number bonds. So it's something that we continue to build from kindergarten to 2nd grade. So when they get to 2nd grade, we're transferring them from the idea of taking your 10s frames you created in kindergarten, how that applies and numbers can be manipulated and changed as we move to number bonds in 1st grade, and then bar modeling completely begins in 2nd grade, and we're able to transfer that knowledge we're building.
And we'll see that on the next slide. This slide just shows you a visualization of the 3 main types of bar models that our students will be exposed to. And as they're introduced introduced individually. But then once they hit 4th, 5th, 6th grade, they're going to be asked to make a decision about what the relationship in the problem, how that dictates the visualization that they're creating. So again, on the top, that part-whole relationship, typically going to be seen in addition and subtraction problems. The comparison model, where we're looking at, really can be used in any operation depending on the circumstances. And then the bottom model there would be equal parts. So that's when the model we would typically use in multiplication or division, whether we're looking for 4 groups of 5, or dividing a total number of oranges among 10 people, whatever that may be. That's how we would ask students to visually represent that. As Mr. Kerr was mentioning on the next slide here, this is a picture of what bar modeling, how it's introduced in 2nd grade. So we're building that connection here between the concrete with the unifix cubes. The first example there was an addition problem. This example here is a subtraction problem, showing the part-whole relationship. So in this problem, Will buys 24 eggs, he breaks 7 eggs. How many eggs do not break? So in that problem, we know the whole. We know that he started with 24 eggs. So our entire bar would equal 24. Then we know that 7 of those eggs broke, so we know one part. We're trying to find the other part, which is how many eggs do not break. So we could represent that using unifix cubes, which students are using a lot in kindergarten and first grade, and we're making that slow transition, moving through concrete, pictorial, abstract with the students to show that relationship of part, whole. Okay. So here is a problem that our students would be exposed to show really how creating a visualization can really help us get the right answer. Okay? So this problem says the sum of two numbers is 36. The smaller number is 1/3 of the larger number. Find the two numbers. A lot of students, maybe a few of our colleagues, even when we saw this problem the first time, looked at this and said, my numbers are 12 and 24, because 12 is 1/3 of 36. But that's not really what the question is asking. The question is asking that the smaller number is 1/3 the size of the larger number. So what I really need to do is I need to break 36 into 4 equal parts. Because then I know if the larger number is 3 of those parts, the smaller number would be 1 of those parts. Okay? And then I can find the value of 1 of those because I know the value of all 4 of them together. I know all 4 of those boxes would equal 36. So I can very easily divide 36 divided by 4 and find the value of 1 of these boxes, or 1 bar would be 9. So I would know that my two numbers would be 9 and 27.
So in terms of some of the things that will be coming home regularly, we want to go over some of the items you'll be seeing on a daily basis coming home, and also some of the technology that's available for us to use to help support our students. This is an example of our School to Home Connection, which is a newsletter that's sent home at the beginning of each chapter. And in it, there's a letter to the family that explains the skills we're going to be teaching within that chapter. And also there are activities designed to use at home to help support your students with the skills that we're continuing to reinforce each day in the classroom. So this is something that you'll see every chapter, kind of keep an eye out for as it will be coming home. In logging into the math program online, the nice thing about Math in Focus is that it is through the same publishing company that our current literacy program, Storytown, is through. So as you log into one website, you have access to all of the math materials and all of the reading materials both at the same place. So just one login required. And when you get in there, you'll see an area where there's things to do. That's where if a teacher assigns a specific assignment online for a student to do, they would look there. Typically, we don't see that as much in elementary. But we do have My Library and My Test Scores. There are online test scores also not used as much in elementary. But we do have a My Library, which is the most important link that you'll be using. When you click on My Library, it takes you to a screen that's going to show you all of the different resources that are available. On the left-hand side, you can see at the very bottom Mathematics, and below that is Reading. If you click on the Mathematics tab, it will give you a screen like you see here with all of the resources that are available for you to use online. The student textbook is available online as well as the student workbook that we use each day. That's the end of the lesson when we are wrapping up our skill and showing that we understand and have the proof of that lesson. We also have available the virtual manipulatives online, which are right here. The virtual manipulatives are an example of where we take the manipulatives we work with at concrete level within a lesson, can be practiced and extended at home as well. If you could go back one slide too quick. And we also have interactive games online. The nice thing about the interactive games is that we have 3 parts to them, where at the beginning it's a tutorial that explains to the students about the skill and gives them some real-world examples, and using it, followed by some activities after that help to reinforce the skills that they're working with. So these are items that we do have available online. Also online available are math background and support videos. These are a nice tool for parents to use, specifically to get a little bit of background knowledge on the chapter we're going to be teaching. Within each chapter, they give you a quick informational piece, just describing the concepts and skills that will be taught and presented within that chapter. And there's also a section that gives some tips at home for how to help your students who might be struggling with a particular concept. So it goes by chapter, and it gives you some more in-depth knowledge on things you could use at home to support your student if they're struggling. And the chapter content is all presented as well.